in this problem, we're told that we have 11 members on a committee, including someone named Bill. And there are 3 offices that are being filled, and in the textbook they name the offices. In the web work they don't. Nonetheless, just as a side note here, if they don't name the offices specifically, but they still say there are 3 distinct offices being filled, you still have to consider this to be an order matters situation. Let's talk about these 3 things. The first one says is how many ways can the offices be filled? So this means that we don't particularly care whether Bill is one of these officers or not. We would say I have 11 total people to choose from, and I need to fill 3 of the offices. Okay, well, for part 2, in how many of these ways is Bill the chair? Well, let's keep in mind, you use these permutations and combinations to choose for positions that you don't know. If Bill is already considered the chair, there are only 2 remaining offices to be filled. How many people are there available to fill those offices? Well, Bill is no longer available to fill that office. The other 10 people would be. So it's the original 11 minus Bill. So there are 10 people left who can fill that office. We want to select 2 of them. All right, and how many of these ways is Bill an officer? Well, this now no longer nails down what Bill is doing. So we have 3 different possibilities. There could be Bill is the chair, which we saw before, in which case we have 10 remaining positions and we need to fill 2 of those. Or maybe Bill's the secretary. If Bill's the secretary again, we would have 10 available spots and we would need to choose 2 other people. Maybe Bill is the treasurer. And again, if Bill's the treasurer, there would be 10 remaining spots and we'd need to fill 2 of these. Okay, I'm going to grab my calculator here. Okay. All right, so permutation 11, choose 3. And we get 990. Okay. 11 times 10 times 9. Here we would get 10 times 9, which is 90. And then for the third one, this would be 90 plus another 90 plus another 90. That would be 270. Okay. All right, so this is how to do this with the permutation notation, the P notation. I do want to take a second to talk about a second way you could look at this. We have this idea of multiplication principle, which we talk about using in situations where you want to choose one item at a time. And if I wanted to choose one item at a time, an alternative way to do this would be to put out our 3 offices, okay, label these things, chair, secretary, treasurer. So for problem 1, as an example, we would say, okay, so I don't know any of the 3 positions. I have 11 different people who can take that office, 10 that could take that office, and 9 that could take that office. This is a different way to get to the same 990 answer that we did with the permutation notation. Now the way that would work in problem number 2, just as an example, you'd again write down the 3 offices here, but now we're told that Bill is the chair. So there's Bill as the chair. And there's only 10 people left to take this, 9 people left to take this, so there's your 90. And so this is an alternative way to look at the same type of problem. Now there are some problems where this type of strategy becomes very, very cumbersome. So it's important to understand both ways to do this. But in both strategies, as you can see, they get us the same number. So this is the number of ways to fill these offices.